Hello. Hi guys, good morning. Welcome back to a new video. Ki halchal. I hope you guys are doing good. In this, we're going to see problem. Final prices with a special discount in a shop. Now, you are given an integer array prices with prices of I is the price of the ith item in a shop. So you have a shop and the price of each item is given here. Now, there is special discount for items in the shop. So for each item for which you are given the corresponding prices, you have a special discount. If you buy the ith item, then you will receive a discount equivalent to the price of j. So let's say if I am buying, let's say this specific item, then I will receive some price of j as a discount. What is price of j? Price of j is the minimum index such that j is more than I. So if it is I, j should be more than I, and on the same grounds, it is that okay, price of j should be less than or equal to price of I. So as you can see, the first price which is less than or equal to the current price of I is actually my discount price for this current price of I. And otherwise, if there is no such which is less, for example, if the I would have been this, then in the right I have no such price which is less than this price of I, so this will have no discount. Thus this is a corresponding discount for each price. I have to finally return an answer of I is the final price, which means after discount what is the final price. Now if I just simply show you 8 4 6 2 3, the normal very brute force stuff which we can do is I can simply iterate and by say okay, for 4 just simply go on in the right side, find the first price which is less than or equal to 8, that is my discount, simply subtract that thing from myself, and this is the corresponding new final price. I'll go on the right side, first price which is less than or equal to 8, it is 4. I will subtract 4 from this 8. Okay, 4 is the price. Okay, for this 4 I'll go on the right side, the first price which is less than or equal to 4 is 2. This is the discount, subtract it, you will get a value of 2. Okay, for this specific 6, go on the right side, first value less than or equal to 6, 2. Okay, simply subtract it, you will get a value of 4. For 2, right side nothing less, so 2 will remain as is. For 3, I'll simply go on the right side, nothing there, so 3. So this is the final answer with having a discount. So as you simply saw that in the simple brute force, I was standing here, I went on the right side for every index, and in the worst case I can go up till the last index. So for one index I'm going to all the other indexes. So for one index going to all the other indexes, for all indexes I will go to all the other indexes. It will be in worst case O of n square, and because it's an easy problem, O of n square is bound to work. As you can see, constraint is pretty less, O of n square will work, but we will see the better approach. Now, what is the better approach in this? Now, did you see a very standard stuff? What is standard stuff? Standard stuff is that for any specific index, you're going on the right side and searching for the first index on right that is less than or equal to less than or equal to myself. This term is very standard. This is also termed as nearest value slash index to left slash right, which is lesser which is lesser or higher than myself. The way you know that whenever the problems are sorted, you apply or tend to apply binary search or two pointers. This is the same thing which you should know, that if you are asked to go and do some operation for any specific index, go and find the nearest index such that it is lesser or higher, and maybe it is on the left or the right, then you have to note that you apply a monotonic stack here. Again, there is no such as okay, Aryan, how would I know that I have to apply a monotonic stack? That is a complete different story altogether, which I will tell you right now. But this is such like a thing that you should be knowing. That's it, period. Now, how you would know it? Simply see that for this specific case, let's say if I take 8 4 6 2 3, just see that okay, you know that you have to apply monotonic stack. Monotonic stack It simply says that I will maintain a monotonic form. Why it is required? It is simply because for 4, if I have anything on the right side, I would only be requiring which is having the least value. That's it. Now you might ask, Aryan, but what if I have a higher, what if I would have had a higher number, let's say 7 here? Then for him, 2 is not required, 6 is required. That is the reason I will maintain monotonicity. Monotonicity. Now, there are two things. Now, let's say if you know that you will apply monotonic stack here, there are two things. Will it be monotonic decreasing or monotonic increasing stack? That's the first doubt. And second thing is, will you iterate from left or will you iterate from right? Now, people usually get confused. They tend to know, they end up get knowing because this is a very standard terminology. So they know, okay, you have to apply monotonic stack, but then how is the question? And people usually in these cases are very confused on what to do and how to do. Now, simply do the same thing you were told to do. What is the thing you were told to do? You were told that for any index, anything on the right side which is lesser than or equal to him, and just right, which means the first index on the right side which is less than or equal to him, that is my corresponding discount value. So for any index I am only concerned about its right side. So can I say that whenever I have reached I should have known that who is the candidate for him to be his discount value, right? So obviously, again, although you can solve it by using left iteration also, but it makes better sense that you should iterate from right, such that at the point when you are on price of I, you would have already known who is a candidate for him to be as his discount. So I will iterate from the right side. Okay, makes sense. Now when I iterate from the right side, let's start iterating, and with that we will realize what can be the stack value. Is it decreasing or increasing? So obviously for 3 there is nothing in the stack, so 3 will remain as is. For 2, again, obviously when 3 will remain as is when I move to 2, but before that I will push that in my stack. Now for 2, I have 3. Now, your task is, will the stack look like 7, 6, 3, 2, 1, or will it look like 1, 2, 3, 6, 7? This is monotone. Again, you can just say, okay, this is monotonic decreasing, this is increasing. But again, anything you want to say. So this is two patterns. One is actually decreasing, one is actually increasing. So this is decreasing and this is increasing. So what you will put up? Simply realize that you were at 2. Let's say your I index is at 2. Now you have to make sure, okay, firstly, for 2, just look at your stack and see, is there any worthy candidate for you as a discount? Because obviously I told you anything on the right side will be your candidate, and that candidate can be represented by the help of a stack. So you will check your worthy candidate inside the stack. It obviously makes sense that for 2, anything which is higher than or equal to 2 is actually a bullshit thing. Why? Because for right side, 2 will be the smallest value. So anything higher will never be used on its right side, because 2 will be acting as a shield. Okay, if anything is higher, why will I ever go to anything higher? So obviously it makes sense that anything higher I should remove it from the stack. Again, there are two things. I'm removing one thing is because for 2 anything higher is not required, and also for anything on the left side of 2, as 2 is already present, so anything higher will never be used because I'm looking for a smaller value. So I should remove it from the stack, and then I will simply put up a 2. Okay, I put up a 2. And again, this is firstly, for 2, I simply removed it from the stack, and then I realized stack became empty. So the answer for this is 2 itself. But then before moving on to the next index, which is this one, I simply pushed 2 itself. Okay, now I reached this specific index I. Okay, it is 6. I find something in the stack which is smaller than equal to me. Oh, which means this is my answer. This is my answer. Now, if this is my answer, I will subtract it from 6. I will subtract 2, and then I will put it here. Okay, 4. Now, obviously, I should put things in my stack. Now, I will put it in my stack 6. Now, you might ask, Aryan, why did you put up 6? Why you did not remove a 2? Because obviously, if the number would have been 8 right here rather than 4, if I would have had a 8 right here, then 6 would have been the nearest, or I should say, the just right smallest value. So, this is what makes us say that this thing is something of monotonic increasing and not a decreasing, right? Okay, now coming on back, we will simply start iterating again. So I have reached at this point of I. Now, obviously, as we did previously, for 4, I don't want anything which is higher than or equal to him. So I will simply remove it from the stack. Why removing it is not harming us? It is not harming us because as I remove this from the stack, anything on the left side of 4 will obviously first encounter 4, which is obviously lesser. So if I have 4 here, so anything on the left side will encounter 4. Okay, I'm good. Anything higher will never be encountered because 4 will act as a shield. Okay, so I'll simply remove 6, and as I removed my 6, I will keep on removing. It's a simple while loop because I could have a 6 and a 5 here. So it's a simple while loop which will keep on removing things from the stack, from the top of the stack, that until unless I reach my stack becomes empty or I reach a value which is lesser than me. Okay, for 4, lesser than or equal to value is 2. So I'll simply say, okay, 2 is a discount, 4 is the value, no, don't push it. First find the answer for 4, and then, okay, for the answer of 4, the answer is discount of 4 is 2. I will put the discount and the value will become 2, which means 4 minus 2 will become 2. Then before moving forward, push it in the stack. Okay, I pushed it. For this specific index, I will try removing everything which is higher than 8. Okay, higher than 8. Okay, nothing is higher than 8. So 4 is the corresponding discount. For 8, 4 is discount. Answer is 4. And this is your final answer. Thus, what happened ultimately? What's the complexity? In worst case, you pushed and removed every element exactly once, which means operation on the stack for every element was happening at max twice. Thus, the complexity is 2n. That's it. And obviously, you are using a stack. In worst case, you could put all elements like this, which means all n elements. Thus, the complexity is space complexity is O of n also. Let's see the code. It's very simple, exactly as what we saw. That firstly, I need to have the corresponding answer or the result array. I will take my corresponding stack. Now I will simply iterate from the right side, although you can iterate from the left side also, but what makes more sense is this. Now until the stack is not empty and the top value is higher than my current price, I will simply remove it. Why I am removing higher? Because I want anything which is lesser or equal to myself. I want anything which is lesser or equal to myself on the top of the stack. So I'll simply move anything which is higher then me at the top of the stack. Now when I have removed it, either the stack will be empty or the stack will be not empty. If the stack is not empty, then I will simply grab the top, which is a discount, my current price, and this will be my corresponding result, which is the discounted price. If the stack becomes empty, then obviously I don't have any discount. I will put the price as is. Now ultimately when this portion is done, I will simply make sure that current price I should put it in my stack. I will simply push the current price in my stack. The time here in this case will be O of, I should say at max 2n, and again which is roughly O of n itself, and space is also O of n because I am putting, in worst case I can put all the elements in my stack, and that's your answer. Cool, I hope you guys got it. If yes, then please smash the like button. Bye bye, take care, and make sure to join Discord and Telegram. And if not, Twitter is something spicy right now. Bye bye.